Hello everyone, this is 𝐬𝐿𝐭𝐡 and today we are deep diving into third chapter of designing data intensive application, which is storage and retrieval. We will be focusing on all the details of related to storage and how you particularly retrieve that stored data. So if we specifically talk about what is storage is basically how the data will be stored in your database. Okay, so this is storage, and retrieval is just opposite. The data which you stored, how will you retrieve it, how will you extract it out. Okay, so this is your database, you stored this data and you are retrieving this data. This is all we are discussing today in our this chapter. So let's start. Now first of all, what are the databases which power your database? What are the data structures which power your database? So you might be internally using something in there, inside the architecture on hard disk, how data is stored, in memory how data is stored. So when you store this data, what kind of data structure you are using? So before moving to that, like what kind of data structure I am using, why do I have to know? ठीक है, किसी ने डेटाबेस बना के दे दिया, मेरे को डेटा स्टोर करना, मेरे को डेटा रिट्रीव करना, वाई डू आई हैव टू नो हाउ इट इज़ मेंटेन्ड इन द बैक एंड. ठीक है, सो it's like if you talk about Uber level, it's not required. ठीक है, your only requirement is that you should know how data is stored, and you should know the query patterns basically, that this is how you store the data and this is how you retrieve the data. But if you see, there are a lot of databases available right now in the market. If we talk about broad streams, let's say you have two kind of SQL databases. One is SQL kind of databases, which provides transactional support, and then there is NoSQL kind of databases. Okay, so and inside them as well, there are a lot of databases. If we talk about NoSQL, then there is SkylaDB, there is DynamoDB, there is Cassandra, there is MongoDB. So a lot of options available. Similarly, in case of SQL, there is Postgres, then MySQL, then Aurora. So a lot of options available. So if you have some understanding of the internal architecture, the data structures which are in use, you can take a better technical decisions. You can take better business decisions that this particular database will serve my use case better. ठीक है, इंटेंशन समझ में आ गया कि हमें क्यों पढ़ना चाहिए ये चैप्टर. नाउ starting from scratch. ठीक है, starting from scratch, let's say you don't have any database. So how will you store any data in your, say, laptop? ठीक है, this is your laptop. You want to maintain some kind of data for persistence say. ठीक है, so you have written some kind of program. So whenever you execute the program, you want to store some kind of data so that you can access that data again when you execute the program at second time. So what you will do, you will open a file in write mode, and then dump the data here, and then when you execute the program on second time, you will again read this file and then get the data in your input stream. This is how you can basically do. So let's extend it better. Let's assume that you are keeping a key value pair here, that this is my key, this is value, so that I can better store the data. ठीक है, and you are writing the data in only append mode. So if you see, this is your file, you will be only writing the data in the append mode. When we say append mode, you are not updating any entry. Say this is your K1, this is your K2, this is your K4. So you will never be updating any of the keys or any of the values. You will only be appending the data here. Cool. So this is our basic assumption. So we will move forward with it. Now, how will you read the data for a given key? Once like we have stored data only in the append mode in this log file. Now, how will you read the data? ठीक है, स्टोर कर दिया, अब रीड करना है, स्टोरेज एंड देन रिट्रीवल. तो हाउ विल यू रीड दिस डेटा? स्कैन एंटायर फाइल फॉर अक्रेंस ऑफ की. व्हाट यू कैन डू, you can scan the entire file, start from the first pointer and then keep on reading that where my key exists, and then once you found the key, then return the key. समझे बात? Like if along with the value. So this can be the basic operation. So it will be on off operation, and then if the file is huge, then it is going to take lot of time. और time कहाँ है अपने पास? Time बिल्कुल नहीं है. So how can you optimize this? This is your basic problem statement. ठीक है, O1 is the time complexity, the data structure earlier you were using. Now you have to reduce this time so that you can read faster. क्या मैं इसको O1 में कर सकता हूँ? क्या मैं इसको O of log n में कर सकता हूँ? So can you do that? Can you do that optimization? Because we will require that optimization. So what are the optimization you can think of? you can maintain indexes, and once you maintain the indexes, they will make your query faster. Now if you specifically want to understand more around indexes and how, what, like a basic understanding of indexes from scratch, we have specifically created a video on our YouTube playlist on system design, so you can go check that out by go check that video, and you will get the gist of it, like what it is, like how, all those details. Light आ गई वापस, चेहरा चमक रहा है मेरा. So now the basic this specific point we also discussed in that video as well, that if my indexes is making my queries faster, okay, what you are doing in indexes, you are basically storing the data in a way so that your retrieval is faster, okay. You can have a lot of data in your tables, the databases you are maintaining or the log files you are maintaining. So how can you make them faster? You basically created indexes on top of that data, okay. So you will get that idea. But the one question comes is, if indexes makes my queries faster, should I index all the data? समझे बात? Should I index all the data which is present in my log file, which is present in my database? No, we should not do that. Exploitation नहीं करना हमें. क्यों नहीं करना हमें? It will make you read faster, definitely it will make you read faster, but it will make you write heavier. Why? So let's say this is your log file and you are maintaining the entries here. Now for each entry, what you are doing, you are updating that entry in index as well. This is your index you are maintaining so that you can query it faster. Now if you increase the indexes, let's say you have 10 columns in your file, ठीक है. So for each of these columns you have indexed the data, ठीक है, कि डेटा कहाँ प्रेजेंट है log file में. तो you have indexed the data. It is making your read query faster. But in case of write, let's say you have to enter one write. So if you have 10 columns and you have created index on all of them, you will have to update 10 indexes as well at the at the time of write. ठीक है. So it is a write intensive operation as you create more and more indices. So it's better to create indexes only till a time या फिर only till a count कि अपना use case सर्व हो जाए. ऐसे नहीं कि बना दो बस, जितने आ रहे हैं उतने बना दो, ठीक है. ऐसा नहीं करना हमें. Like if you might have created data indexes in earlier stage of your data storage creation, ठीक है, but in future you realize that it is not required, so you can go ahead and delete it. This is the thing which we should do. समझे बात? Now moving to hash indices. How will you index the data on disk? We talked about that indexes will make your queries faster. So how will you index this data? So first option is hash index. You might have read about hash tables or how hashing is created. Again, we have a video in our system design playlist which you can refer to get details around it. कंसिस्टेंट हैशिंग का नाम सुना होगा आपने, है ना, खतरनाक चीज़. तो वो दैट विल ऑल्सो कम इन टू आर दिस डिजाइनिंग इंटेंसिव चैप्टर्स. बट इफ यू वांट टू read ahead of it or understand ahead of it, we have video on that, so you can refer that. So how will you index this data on disk? What you do, we are moving with this assumption that we will only provide write queries in append only mode. ठीक है, एक फाइल आ रही है अपनी and you will only be updating the values, not updating, you will only be appending the values to the file and not updating any existing value. समझे बात? तो this is our basic assumption. So what will be your indexing strategy? What you will do, create a in memory hash map. You have created an in-memory hash map where you have key 1 value 1, key 2 value 2, and what you are maintaining in these keys and values. In the value section for a particular key, you are maintaining the offset of location where that data is stored in the disk. Okay, so this is your log file. So refer this diagram. This is your key. So let's say your key is 1 2 3. Now I know on disk where this particular key is located because I have stored the byte offset on where is this particularly present in that file. So in this case, I don't have to traverse one by one this file. What I can do, since I know the byte offset of that file, of that particular key, I can directly go to that key. Let's say I found K4 का offset which is present here. So this is O1 of operation. समझे बात? So from O of n, we have made it O of 1. Optimization हो गया read में. So this is what we were looking for. and this is actually used by Bitcask as well, which is storage engine for RAG. Now let's say like this will solve our use case, but what if the number of keys are huge? What if the number of keys are huge? Then will you be able to maintain all those keys? Will you be able to maintain all those keys in memory? Because you might have limited memory for your machine. ठीक है, so उस पे आते हैं हम. उससे पहले like how this particular use case can which kind of examples or which kind of use cases can hash table solve when you are maintaining this kind of scenario. ठीक है, so let's say you have limited set of keys, like we have videos and you want to maintain views for these videos. ठीक है, so for a particular video there will be only one value कि इसके views कितने हैं. ठीक है, now and for v2 you will have views, so we'll have limited set of keys in these scenarios. So in these kind of scenarios it will be helpful, but how will you ensure if you goes out of space, or like since in this case when you are maintaining the data, you are maintaining the data in append only mode. ठीक है, in append only mode, so your data will keep on increasing. कि मैं डेटा को अपडेट नहीं कर रहा, मैं डेटा को डिलीट नहीं कर रहा, एंड आई एम ओनली राइटिंग द डेटा इन अपेंड ओनली मोड दैट व्हेन एवर न्यू की कम्स you will append the data. ठीक है, तो it might be possible that for v1 earlier views were 1 to 3, now views increased, then v1 became 1 to 4, then v1 became 1 to 5. So what you are doing, you are not updating the existing key here. The v1 is not updated, but we are updating like we are creating the entry again with a new view count. So in this case what it will happen, there is a possibility that, and it will happen, ठीक है, if there is a large scale we are talking about, this will happen that the disk is running out of space. Now what you can do to solve this problem? There is problem, there is solution. ठीक है, if there is problem existing, then we have to find a solution for it. So what you can do, you will do that the files which you will have created, the log files which you have created, you will break these files into segments. ठीक है, s1 s2 something like this. Cool. And whenever one file is filled, let's say I have specified 1 MB for one file, so whenever I am done with the 1 MB storage, I will move to another segment. But in this case also you are not solving the problem, you have broken down the file, but again it is going to consume the space. ठीक है, क्योंकि आपने फाइल्स एक फाइल की बजाय you have created multiple files, but still you are consuming that space. So how can you delete some files? ठीक है, if you think about it, if I want to save the disk space, how can I do it? फाइल को डिलीट कर दो जो काम की नहीं है. अब काम की कौन सी फाइल नहीं है? वी हैव टू फिगर दैट आउट. तो हाउ कैन यू फिगर दैट आउट? यू फिगर दैट आउट, किधर गया अपना, ये रहा. You figure that out with the help of compaction. Now what is compaction? You will remove the duplicate keys in log and only keep recent update. So the example which we discussed here, right, we are maintaining the views for v1, it was 1 to 3, then 1 to 4, then 1 to 5. So if I talk about which is the data which is useful for me, this is the only data which is useful for me. v1 is 125. The earlier data v2 views, then v3 v1 views of 1 to 3, then 1 to 4. These entries are not useful for me. ठीक है, if I query for data, the data which I want to be retrieved is 1 to 5, not 1 to 3 or not 1 to 4. So in this case, can we delete these entries? So this is how it's done in compaction process. Like the complete process is called compaction, where you remove older entries and you only keep the recent update. If we talk about one example, let's say these are your videos: v1 23, v2 25, v1 31, v3 71, v1 91. So if we talk about the final update, or like the recent update which we want is for v1 it's 99, for v2 it's 50. ठीक है, एंड फॉर v3 it's 73. समझे बात? most recent segment it's not found, check segment now. ठीक है, so this is related to how you will query this data. So since you are maintaining only recent entries, how you will update how will you try to find this data? ठीक है. So first you will, what you will do, you will try to retrieve this data from the in memory hash table you are maintaining. If the data is not found, move to first segment. ठीक है. If data is not found in first segment, move to second segment. समझे बात? Why? ऐसा क्यों कर रहे हैं हम? If the data is not available in let's say your in memory hash table, then it might be possible that there is no recent update in this. Now it might be possible that it exists in S1. Then if it's not exist in S1, then it might be possible this entry is too old, then it might be present in S2. So you can move along the segments to figure out where it exists and then return the actual key, the value of the key. ठीक है. Now on the implementation details, how you will implement this data structure which we talked about, कि आपको in memory hash table रखना है, disk पे segments में data store करना है. So how will you implement this kind of thing, this kind of actual logic in place? So first one is the file format, which kind of file format you are maintaining so that you consume minimum possible space on disk. Binary is one possibility. ठीक है. Binary में you will consume the minimum possible space on disk. You can encode the length of string in bytes followed by the row string, which when we say row string, it's the value of the key which you are maintaining. Now how you record the data? So this actually we discussed, we created one video on Discord architecture on how you store billions of messages on using Cassandra. So there we talked about one issue related to deletion, which is called tombstone. What we do when we delete the data, let's say this is your log file. So when you delete the data, you will just mark that this is deleted. So whenever you read this data, you can ignore this value or you can skip this value. So these are called tombstones. So this is how it is handled, or this is how it's done, how you delete the data. It is not actually deleted in first place. It is just marked, or like you can just keep a flag here that this is deleted data, and whenever the compaction runs, it can actually remove this entry. Okay, let's say I have scheduled this compaction for 2 days. Now after 2 days, this flag value will be deleted. Crash recovery. What happens if your file the hash table you are maintaining is crashed? So what you can do, maps in memory will be lost in events of crash. So what you can do, you can keep the snapshot of the hash table which you are maintaining in memory to the disk. Okay, so whenever there is a crash happened, you can retrieve the data from disk. Partially written records, it can happen that I was trying to store the data and at that time the crash happened. So you can maintain checksums to ensure that you ignore the partially written data. समझे बात? On concurrency, what if two users are reading the data at same time? So can it cause problems? It can only cause problems. It can only cause problems if there is a single entry. ठीक है, there is single entry K1 and two users U1 and U2 are trying to write to it simultaneously. But since we are only storing the data in append only mode, it will not create any issues in case of write or read. Multiple users can read simultaneously. Now the basic question, ठीक है, we discussed that like when we append the data, we have to there can be issue of disk size, then we have to run compaction so that earlier records can be deleted and merged. So why not update the existing value? Viable solution, viable approach. ठीक है, instead of appending data, why not update the existing keys? And why not why just keep appending? What's the benefit you are getting out of it? So why not? The first reason is it's much faster than random writes. So when we say random writes, let's say this is your log file, okay, and you have maintained this K1, K2, K3, K4. Now whenever new entry comes, we said, let's say and new update comes for K3. So what you are doing in this case, you will create a new entry K3. But if you want to update the existing value, now let's say this is your disk, समझे बात? तो डिस्क की नीडल घूमती रहेगी कि मेरे को अभी यहाँ राइट करना है, अभी यहाँ राइट करना है, इन केस ऑफ मैग्नेटिक डिस्क. नाउ व्हाट यू विल डू इन केस ऑफ append only mode, this disk was here, ठीक है, you will write the data here. But if you want to update a particular entry, this has to be moved back here. ठीक है, then right here. So the disk will keep on moving. So if we talk about the complexity or the time it takes to write the data, it's much faster in case of append only mode as compared to update the entries. This is one reason. Another reason, the actually we discussed around concurrency and crash. So it's much simpler in case of append only mode. Like it's easier. Concurrency example we talked about that since we are keeping multiple values. Okay. So since we are keeping multiple values, we don't have to do anything specifically to handle concurrency. It will be handled automatically. Now there are some limitations as well, which we mentioned few time back, that hash table must fit in memory. Data will grow. So how will you ensure that hash table you are creating is fitting into the memory? And the range queries. What if I need data between K2 and K4? ठीक है, the data here is not sorted. समझे बात? जैसे ही अपनी कीज़ आ रही है, वी आर डंपिंग दोज कीज़ इनटू आवर फाइल, सो द डेटा इज नॉट स्टोर. व्हाट इफ आई नीड ऑल द डेटा बिटवीन K2 and K4? Now this data can be present anywhere in this file, so I have to again run this O and of operation. The byte offsets we are maintaining in hash table is not helpful in this case. So there are these two reasons. Now if there are reasons and if there are limitations, we will try to solve them definitely. ठीक है, problem है, solution निकालेंगे. तो how you can do it? You can do it via SSTables and LSM Trees. नए चीज़. So let's deep dive into these. What are these? ठीक है, first of all we will discuss what are these, and then we will try to discuss how they are internally implemented, how the data is stored, how data is retrieved and all those things, and what kind of databases uses those to store the data. So what we are doing, we are trying to optimize the limitations which we discussed about. ठीक है, अपने पास limitation है कि we want to handle concurrency, then we want to handle range queries, all those things. So how can you do it? You can do it using SSTables and LSM trees. Now what you are doing, you are changing the format of segment files, how segment files are stored. ठीक है, and what is the new format you are looking at? Make sequence of key values pair sorted by key. ठीक है, if this example only, right, if K2 and K4 are sorted, now if I want to run this range queries, I know that K3 is in between this data. समझे बात? So if you are maintaining the data in sorted form, it's easier to run those range queries to get all the data which is between these two queries. So this is how it helps. And this is called sorted string table. जो SS table हमने बोला, you are maintaining the key value pairs in sorted order, and this is called sorted string table, SS table. Each key should appear only once in merge segment, handled in compaction process. This we already discussed above as well, that whenever you are doing compaction, ठीक है, each key will be present only once only. You are removing all the older entries. समझे बात? Now merging of segments, how this merging of segment happens? Algorithm is similar to merge sort. कैसे होगा? Let's take this example. You might have solve that question on Geeks for Geeks or like any of the platform, LeetCode or any platform. ठीक है, कि there are multiple arrays given in sorted form, how you can combine them or how can you find a minimum kth element. So it's kind of similar to that. ठीक है, अब कैसे काम करेगा ये? What you will do, you will read the input file side by side. So there are your three segments, you will read them together side by side and you will look for first key in each of these files. ठीक है, यहाँ पे I है, ये J है, ये K है. You will check which is the lowest file, which is the lowest value in each of these segments. So in this case it's 5. ठीक है, now you will repeat this process, and if there is this is the edge condition, then what if the same key exists in multiple segments? Then you will pick value from the most recent segment. This is what you will do. And which is the most recent segment? S1 is your most recent segment, then S2 is most recent segment, then S3 is most recent. So this is the order of their कि कितने बूढ़े हैं वो. How older is the segment? ठीक है, so this is the algorithm you use. So you got 5 and then you will move to you took 5, you will move here, then you will compare these values. ठीक है, so we have V2, V5, V1. Okay, so this value will be discarded, right? Because V1 here we have V1, here we have V1, so we will pick 11, not 5. ठीक है. So right now you have here, you are here, your I is here, your K is here, and your J is here. Now you are comparing V2 equal to 3, V5 equal to 9, and V2 equal to 9. Cool. So what is the value we'll be picking? Which is the lowest one? You have V2, V2 9, so you can discard this value. There are equal values, you can pick any one of them. Let's say we pick V2 equal to 9. Okay, so let's start from here. Now you have K equal to here, I is here, and your J is here. Now again your 3, 9 and 23, which value we will pick? We will pick 3. समझे बात? So this is how you will move forward. This is the algorithm basically you use to merge the data which you have present. Now how you will search this data? ठीक है, merge कर दिया हमने, ऐसे merge कर दिया, like we have multiple segments. This is how the merge will look like. Now how you will search for a particular key? What you will do, you don't require the in-memory offset in this case to search for data. What you are doing, you are maintaining just the offset of some of the keys. You are not maintaining offset of all the keys. You are maintaining offset of some of the keys, and then you can traverse between these offsets to find a particular key. ठीक है, जैसे in my example I have K1, K2, K3, K4. So I will not store offsets of all these keys. I will just store, let's say, offsets of K2 and K4. So if I have key somewhere, let's say I got the key K2. Now I know that it will be present somewhere in between K1 and K4. So I can just traverse this and then get the data. Why we are doing this? This is helping in two operations, two benefits we are getting. One is we are saving the disk space. ठीक है? Since we are not maintaining all the keys, we are saving the disk space, and it will reduce the IO. Why reduce the IO? Why reduce the IO? Because the data which you have stored, the data which you are traversing is less as compared to earlier. ठीक है, in the earlier case you are maintaining all the keys, and in this scenario you are maintaining just few of the keys. Kind of ऐसा हमने कर दिया कि मान लो 3 की एक की बना दी हमने. ठीक है, समझ रहे हो बात? सो यू कैन थिंक ऑफ दैट में, मतलब दैट मैनर. द फैक्टर कैन बी एनीथिंग डिपेंडिंग ऑन द यूज केस और डिपेंडिंग ऑन द डेटा स्ट्रक्चर और डिपेंडिंग ऑन द डेटा स्टोरेज. But the uber idea is that we are mixing or we are merging some of the keys, so that whenever you try to retrieve the data, you can traverse in between those keys to get the particular key. Now how your SS table is constructed and how it is then maintained. एक बार construct कर दिया, फिर maintain करना है. Construct कैसे होगा? For any write query, जब हम बात करते हैं कि construction, we basically mean how will you write data to SS table. So for any write query, what you will do, you will keep a in-memory balance tree structure which is called mem table. यहाँ पे balance tree structure we can use AVL tree or red black tree, any of the balanced binary tree we can use to the data we are creating. ठीक है, sorted data, like we have to maintain the keys in sorted order. So for to maintain that, what you can use a balance tree data structure, and then after a certain threshold, ठीक है, after a certain threshold, let's say 1 megabyte or 1 kilobyte, you will move this data to disk, which is called SS table. The same mem table is transferred to disk. It was in memory, so we called it mem table. It is on disk, then we are calling it SS table. Now for each of the read query, what you will do, you will search in the mem table, then most recent segment, and then so on. The earlier approach we discussed, like first you will search in the hash table, then you will move to segment S1. If it's not present in S1 as well, then you will move to S2 on the basis of which one is the most recent. So your mem table is most recent, then S1 is most recent, then S2 is most recent. So accordingly you traverse in them and then try to find that key. And from time to time you have to run the merge and compaction process, the algorithm which we discussed, that you have to delete some entries and then you have to merge the data. Disk space हमें बचाना है, समझे बात? So this is how your construction looks like. Now if we talk about the performance of database which is built on LSM tree, reads can be slow as you traverse from one segment to another. So we talked about that if the data is not available in mem table, you will move to S2, then you will move to S2, you will move to S1, and then you will move to S2. तो यहाँ पे if you see a problem that read can be slower, समझे बात? Because you there might be a possibility that you have to traverse multiple segments to find that particular key. And to solve this use case, we generally use Bloom filters. As of now, we don't have a specific video created focused on Bloom filters, so we will create one in future. If we talk about the Uber idea, what Bloom filter is, it will help you to determine or kind of approximate that data is available or not. ठीक है, let's say I got an query to find key K2. So what I can do, I have to traverse this entire segments. ठीक है, मेम टेबल में नहीं मिला, S1 में गया, S2 में गया, so I have to traverse this. Is there a possibility or is there a way that I can figure out beforehand if K2 is available or not? So this is how your Bloom filters help. Data structure is helpful for approximating contents of set. ठीक है, and it will tell you if key is present in DB or not before you have to entirely traverse that DB. So this is how it helps. Moving to compaction and merging. So we mentioned that we have to run time to time compaction and merging. तो वो करना कहाँ पे, मतलब कब करना है basically, ठीक है? Like what is the best time that I can run this compaction process or run this merging process? What's the best time so that my reads and write are not impacted? Because this compaction merging is background process which you have to run apart from your reads and write queries which user is performing. ठीक है? So it should not impact जो यूज़र काम कर रहा है, उसको नहीं पता लगना चाहिए कि भाई बैकग्राउंड में कॉम्पैक्शन रन हो रहा है या फिर द मर्जिंग प्रोसेस इज इन प्लेस या इट्स रनिंग. सो व्हाट यू कैन डू, there are two ways and it depends on database, like which way they are using. One is size tiered and one is leveled compaction. HBase uses size tiered, Cassandra uses both. Level DB and RocksDB use leveled compaction. So this is a very small description about this. Smaller, so in case of size tiered, if as I see from the name itself, your multiple like small SS tables will be successfully combined to larger SS table. And in case of leveled compaction, it will be based on keys, and basis the keys it will be splitted into multiple levels. So key range is split up to small SS table and all data move to separate levels. समझे बात? ठीक है, ये एक लेवल था, यहाँ पे मान लो टाइम T1 का डेटा है, then it is moved to again T2 which level 2 which has data related to T2 timestamp. समझे बात? So this is all about LSM trees and SS table. Now let's move to another data structure, which is B tree. We will talk about the use cases where these two specifically are used and what are the difference and what are the benefits of using each one of them in follow-up section. But right now let's focus on the B tree, which is another data structure which is used to store the data in backend architecture. B tree पे अगर आपको focus करना है, we have a project in our GitHub repository, deep database, जहाँ पे हमने इम्प्लीमेंट करने की कोशिश करी थी यूजिंग बी प्लस ट्री. सो यू कैन रिफर दैट. यू कैन ऑल्सो check some open source articles on Geeks for Geeks. I think there are some articles available on the implementation, so you can refer that as well. It's easy implementation. ठीक है, I will share some links with you. So first of all, it's not a binary tree as the name represents. So B tree doesn't state for binary tree. It's balanced tree. When we say B tree, it's a balanced tree. It's not a binary. Binary मतलब दो बच्चे नहीं है, इसका बहुत ज़्यादा बच्चा. Now what is B tree? So here as well we are keeping key values pair sorted by key on disk basically. B tree break database into fixed size blocks. We will talk about it right now. Each block can be identified and addressed using which one page refer to another. So when we say about, let's take a very high level view. What we'll do, let's say this your entire disk. ठीक है, यहाँ पे एक ये स्पिनर लगा हुआ, ये घूमता रहता है. इन केस ऑफ मैग्नेटिंग SSD में ऐसा नहीं होगा, बट लेट्स से दिस इज योर डिस्क. ठीक है, हार्ड डिस्क है अपनी. नाउ इन योर हार्ड डिस्क you have lot of space available. Now what B tree will do, B tree will construct pages of let's say 1 KB each. 1 KB P1, this is P1, this is P2 1 KB, this is P3 1 KB. Cool. So this is how you have created multiple pages in B tree, the blocks which we referred here, and each block can be identified by the address. So I will know which address my block is present. समझे बात? So you are maintaining the basic reference. Now how you will store the data in your B tree. Let's say you have your all these keys 100, 200 and 300. So this is how your B tree will look like. This is your root node. Okay, this is your root node. Now all the keys which are less than 100 which go into this direction. Okay, तो यहाँ पे all the keys which are less than 100 will go into there, go into here. समझे बात? All the keys which are in between 100 and 200 will go in here, and all the keys which are in between 200 and 300 will go in here, and then so on and so forth. समझे बात? 300 से ज़्यादा है वो इधर आएगी. Now again you can break these keys into more child nodes. You might have got the gist. Now, how you will handle the crashes in B tree? What if the hardware crashed at time of any update? What you will do? Okay. What if the B tree you are maintaining? Okay. The B tree you are maintaining, it crashed at the time of any update. What will happen and how will you recover from it? How you will do? You will maintain an additional data structure which is called write ahead log WAL, and it will help you to recover the data which is lost, and so that you can construct a B tree again from the data. This is again a append only data file, append only file which keeps the log of what updates are happening in the B tree. So whenever a new update comes to B tree, first it's written to WAL, write ahead log, and then it is actually updated in the B tree. समझे बात? ठीक है. So this is how this is the very good, very basic description about B tree, how the data is stored and how the data is retrieved, and how you handle the crashes. Now there is one specific thing which we will discuss during the comparison, right amplification. This will be used in our comparison. So what is right amplification? So let's say you are updating any values in a DB. ठीक है. This is your key1, this is your K2, this is your K3. Now let's say you updated one entry K1. Now how much write it cost, or you are inserting a value K4 here, so how much write it cost. ठीक है. जैसे for example, if I keep the if I update the K4, does it require any more writes? Or like even if I don't update the K4, does it require any further writes in other keys? Like let's say in case of B tree, if this key range is not sufficient for now and I want to break it further, so let's say our key comes of 50. Okay, so if I want to update in the root node itself, then I will have to break the data, break the root node, and then update the references, the address which you are maintaining. Okay, so in this case a write is cost. So this is how a write amplification is defined for a particular operation. Okay, for a particular database in general terms. Now if we compare about LSM trees and B tree, LSM trees are specifically faster for writes. Why? Because we are dumping the data. We are dumping the data and it's in append only mode. So it is optimized for write queries, and B tree is optimized for reads. LSM trees can sustain higher write throughput because and again the reason is the append only mode, and there is more write overhead. Why? Because we have to update the existing pages as well, the references which we are maintaining. So there is more write amplification. Can be compressed better. We already discussed that how it is done. In case of B tree, it can leave some spaces unused due to fragmentation. So we mentioned that we will create pages in B trees. Like let's say I created pages of 1 KB each. Okay. So it is a possibility that the data you are storing is only less than 1 KB. ठीक है, it is only let's say 800 bytes. So in these kind of scenarios you will have left out some space, so it can cause fragmentation because it will not be useful for any other pages. So you will have to optimize the page size first, but there is again always a possibility that fragmentation can occur and you are consuming more space as compared to LSM trees. Again, moving to another feature, compaction process can affect ongoing read write. We discussed that compaction is a process which runs in background, so it can affect the read and write because sometimes we have to run it. In case of B tree, each key is present at single place only, so it offers strong transactional support. So this is one issue which can occur in B tree. This is one benefit this is one issue that you have to figure it out in case of LSM trees. But in case of B trees, since a single key is maintained, it offers strong transactional support. Why? क्योंकि एक ही एंट्री है अपने पास, ठीक है, यही अपडेट होगी. Moving to some another kind of indexes, we already discussed hash indexes. There are some other kind of indexes as well. One is secondary indices. So if you used DynamoDB or any of these tables, probably MySQL as well, you create some indexes on top of it as well. So those are called secondary indices. ठीक है, जैसे one is basis of primary key. ठीक है, प्राइमरी की, सो यू कैन रिट्रीव द डेटा बेसिस प्राइमरी की. व्हाट इफ आई नीड टू रिट्रीव सम डेटा बेसिस सम कॉलम वैल्यू, so this is not your primary key. How can you do it? You can build index on top of it, which is called secondary indices. Another one is if you want to provide support for full text search or fuzzy indexes, how you can do. One similar solution is Elasticsearch, which is built on top of Lucene. Another is Solr. So you can you can use these kind of indexing solutions to index your data and then provide your support. Example could be that, let's say I'm searching for apple and actual words the actual word store is apple, and then I am searching from APLE. So can you return this data from indexes? So this is how your fuzzy indexes can help. Similarly, it can help you to give you synonyms. I search for apple और ये मेरे को सेब दे दे. ठीक है, so this is how it helps. So we have discussed that how you are maintaining the indexes on disk specifically, like how you are updating the data, how you are storing the data. There are also some solutions available in market like Redis, Memcache, and all those solutions which provides caching support on memory. So if we talk about in-memory databases, Memcache is the one such solution, and it is basically used for caching purpose. ठीक है, कि I have, like, my primary source of truth is some database, and to make the queries faster, I am keeping this caching solution Memcache in my memory, so that I can retrieve the results faster for the user queries. ठीक है, so Memcache is one solution, and they are not intended for a durable solution. ठीक है, they are intended for a purpose, like you can make them durable definitely. You have to build some mechanisms on top of that. There is always a possibility of doing that. ठीक है, but in general, the caching solutions are used as a backup mechanism, or are just not a backup mechanism. Backup is different. Just a way to solve the queries faster. So in case my cache crashes, or like the Memcache solution you are keeping is crashing, you can update that cache again, or you can fill that cache again by using the data from disk, the database, the primary source of truth we are talking about. ठीक है. There are some databases which provides more durability as compared to one we talked about, Memcache. So what they will do, they will dump periodic snapshot to disk, so that in case of any issues they can retrieve the data from disk and then update the cache again. Redis and Couchbase provides weak durability by writing to disk asynchronously. When we say asynchronously, synchronous मतलब जैसे ये वो कैश में आया वो डिस्क में नहीं जाता. ठीक है, this is what synchronous solution means. Like you have written this solution into Redis here, like in memory. ठीक है, in memory, and then you move to disk. So this doesn't happen synchronously, this happen asynchronously. Then it can be possible that some of the updates are missed. So this is the general idea. Now again, this will we have to figure out what is our use case to decide on which database. So if we talk about two broader criterias, one is transactional support kind of database, and one is analytics kind of database. ठीक है, OLTP and OLAP. Now if we talk about the differences between them, OLTP are more suitable for sorter queries, or like you retrieve some kind of data, you query it for some kind of data and then return that data. ठीक है, if we talk about OLAP, they are kind of data that you have, they are kind of databases which are extensively used to run some kind of aggregate operations. ठीक है, you have, let's say this is your huge set of data and you want to perform some kind of aggregation on top of it. Let's say some operation. ठीक है, कि total profit कितना हुआ. But in case of OLTP, you want to return some small number of records from the database, okay, to serve your user query. So this is like the very basic difference, or very the most important difference, okay. How, what kind of use case you are looking at. क्या आपको कोई एग्रीगेशन करना है डेटा पे? नहीं करना, तो OLAP OLTP पे जाओ. What about write? The writes can be random access, low latency writes. It is ETL. Basically, ETL we will discuss, extract, transform, load. कि कहीं से data extract करें, then we will transforming this data, and then we will loading this data to our analytics database. The data size can be GB to TB, and this can be TB to PB, because what we are doing some kind of analysis that is kind of, you might have some kind of historical data, ठीक है. So for that historical data you will do some kind of analysis, and then aggregate those results and then return those results, and they can be taking more time, ठीक है. यहाँ पे we are not serving some kind of user queries. Your direct customers are not, they can be, but your direct customers, the direct users, the general public is not the customers here. It can be possible that the marketing team is using it, the business intelligence team is using it to make proper or like better marketing decisions, so that they can market that product better. So if we compare it, let's say these are your two database where you are keeping user DB and inventory DB for your system. You run a e-commerce website where you maintain the users, like what all users you have, all those their interest and all those things in the user DB, and then we have inventory DB where you keep all the inventories. ठीक है. Now if we want to do some kind of analysis on top of it by using both these DBs, either you run join queries on this, but ज़्यादा टाइम लगेगा, and you can do it, but it's not recommended, ठीक है, because they are intended for some specific purpose and we are trying to use them for some another purpose, ठीक है. If data is small, then you can do it, but if data is growing and growing and we have huge data, it's better to use some other mechanism such as OLAP, data warehouse, ठीक है. So what you will do, you will extract this data from let's say this is your Lambda running, which runs your Spark job, or it could be your EMR cluster, ठीक है. So it will extract the data from here, it will transform this data, ठीक है, on whichever format we require. Let's say you have these 3 columns here, then you have your 3 columns here, you need 5 columns here, ठीक है. So you did that transformation here, and then you will dump this data here, basically load operation. समझे बात? So this is all about OLTP and OLAP, how you distinguish them and how you can choose a particular solution basis your use case. Now moving to another kind of data storage, which is column oriented data storage. If we talk about why we need this kind of database, ठीक है. So let's say you have a table here, ठीक है, and these are your rows. Row 1, R1, R2, R3, R4, R5, ठीक है. And then you have, let's say, columns C1, C2, C3, C4, C5, C6, ठीक है. Now let's say for a particular query I want to return R4 column C5, ठीक है. So what I will do in general, I will go to R4, ठीक है, I will go to R4 and then I will extract the column 4 from here. Now what if you have 100 columns in here? You have to figure out that row, you have to figure out that column from those 100 columns, ठीक है. So can we optimize that? You can optimize that by using column oriented data stores. So the example which we discussed, like the table can have 100 columns wide, but we might be accessing only 4 to 5 columns at a time, or like single column at a time. So we don't have a use case to read all those columns, but we are reading it anyway, ठीक है, क्योंकि हमें स्पेसिफिक कॉलम रिटर्न करना है उस बेस पर्टिकुलर रो के अंदर से. So we are trying to optimize that. What you can do, you can use column oriented approach where you store the values in like from each column together instead of rows, ठीक है. Instead of maintaining it via rows, what you do, you store the data basis rows, so you will combine all the rows together, all the columns together in this scenario. What are the benefits? Like one benefit which you are getting is this, that you can extract that particular column from there. And another example is the column compression is easier. Why? Because there is always a possibility that values are repeated. Let's say for here C3 represents inventory present. ठीक है, so it can be true, it can be false, it can be true, it can be false, it can be true. ठीक है, so if you see the values are repeating, so there are chances, like there is a option, there is a possibility that you can compress this into a single field or single attribute and then you can decode it. ठीक है, एनकोड कर दिया कि हाँ ये वैल्यू ये रिप्रेजेंट करता है. सो इफ देर आर सेम वैल्यूज प्रेजेंट एंड इट विल बी अ पॉसिबिलिटी इन केस ऑफ columns that the same value is repeating multiple times, so there is a chances of column compression. It's easier to handle. If we talk about some examples, Cassandra and HBase, they are not strong candidates of column oriented, like they are based on this approach, but there are few let's say वो नहीं बोलते कि 100% प्योर वाली चीज़ नहीं है. ठीक है, so they are not 100% pure column oriented. Why? So they store all the columns for row together along with the row key, so they maintain row key as well, and they don't use column compression, which is a good feature to have. ठीक है, so this is all we will be discussing today. I hope you enjoyed the chapter. I hope you learned some new things today. Let me know in the comment section any feedback, any suggestions, any things, any more things we should cover, any more examples we should take to understand the concepts which are discussed in these chapters. We will meet again in our next video, our chapter 4. Till then, stay safe. Tata. Bye bye.